Newton's Laws of Physics. Presented by James Champion, Mr. Castilleja's 8th period.
Newton's first law of physics. Newton's first law of physics states that objects in motion will stay in motion, and objects at rest will stay at rest unless acted upon by an unbalanced force.
As an example of Newton's first law, we're going to creep up on this unsuspecting melon, and we're going to see whether he's moving or not. As we can see so far, the melon has not moved. It has stayed consistently still. But it maybe if we poke it with a stick, it'll jump. Oh my god. It shook a little bit, boys, but she's still the same.
This is because Newton's law states that an object in rest will stay in rest unless a force acts upon it. Thus, this little melon will stay like this forever, infinite, or it will stay like this until the end of time, unless other forces act upon it and move it, or cause it to deteriorate.
Hello. So as you can see by the position of the ball will not move. This is because it is on a very, very, very horizontal surface. Thus, there is no force acting upon it. As of right now, the ball will stay like that forever. It will never move. But once you start to add another force to it, such as gravity by the moving of the slope, you can see that the ball begins to shift in position. And thus, once the slope changes and the gravity is allowed to act upon it fully, the ball will fall.
Newton's second law of physics states that force exerted is the product of the object's mass and acceleration. Therefore, an object's mass multiplied by the object's acceleration will give you the force. As an example of Newton's second law of motion, I have two different objects of different masses. Although the acceleration on both of the objects may be the same right now, the masses differ. And thus, since the textbook's mass is higher than the Rubik's ball's mass, it should have a higher force on impact. So because of this, I'm going to drop these two items at the same height into this memory foam mat, I should say, and they will create indentions accordingly. So here is the book, and here is the Rubik's ball. And as you can see, the Rubik's ball left little to no indentation when compared to the book that has left an actual imprint on the mat. Second law of motion states that force is equal to mass multiplied by the object's acceleration. In this demonstration, I'm going to be getting two different objects with different masses and with the same acceleration. I'm going to show their impact on this paper towel held together by two of the same Coke cans. So in this experiment, I'm going to be lifting up one of the objects at the same height, dropping them on the paper towel, and seeing how the impact differs between both the pen and the water bottle. So the difference between these two is the mass, and because of that, the objects will have a different force. As you can see by the pen, I'm going to drop it at the top of both cans. The cans are able to withhold the force. And after fixing the paper towel, that way its positioning will not be a factor, I will now be dropping the water bottle. It will be dropped at the same height, and it took down the paper towel. The difference in reaction between the pen and the water bottle is due to the difference in mass. The acceleration is the same. Both of them were accelerated by gravity, but the impact differed because of the mass of the two objects. Newton's third law of physics states that for every action, there is an equal and opposite reaction. As an example of Newton's third law of motion, I will be putting pressure on the top of this cup, which will in turn put pressure on the tabletop, which by Newton's third law will exert an opposite force that will in turn crumble the cup. Newton's third law states that for every action, there is an equal and opposite reaction. So in this demonstration, I'll be showing you how my hand pushing down on the top of this lid will not only cause pressure to go upon the lid, but also an opposite reaction that will come upon my hand. So as you can see, as my hand pushes down on this lid, not only is there pressure being put on the can, but also on my hand, as you can see by the mark thus.